Wrong thing. All right. So simplifying radicals, definitely on the test. Square root of 99. It's going to go into square root of 99. 9. 3 is not a perfect square. 9 is. Okay? Square root of 9 times square root of 11, that's 3 root 11. Now again, a lot of people still resisting this whole process for simplifying square roots. Still want to use factor trees, still want to do those things, but I see a lot of people using factor trees getting it wrong every time. So this is really a better way once we get to it. 3 root 6 times 2 root 10. When we multiply, really this means 3 times 2 times root 6 times root 10. So that's 6 root 60. And we have to simplify the root 60. So what perfect square goes into 60? Well, 60 itself is not a perfect square, so we go to half of 60, which is 30, which is not a perfect square. We start looking at perfect squares less than 60. So 25, 16 going to 60. No. 9, 4. Yeah, 4 times 15. We write that out. We don't try to do this in our head, but we actually write it out. Simplify the square root of 4, which is 2. And we get 12 root 15. Root 10 over root 15. A lot of people rush here to rationalize it. Multiply by root 15 over root 15, but that's not necessary here. Not initially. What should we do initially? What do you think, Jared? Reduce it, yeah. 10 over 15 reduces to, or 2 over 3, yeah. Sorry. Now we simplify it. How are we going to rationalize that? Root 3 over root 3. That gives me root 6 over 3. So simplifying radicals is definitely going to be part of this quiz. The first few questions on this chapter test are just that. It's a review. And it's an important skill to have as we're going through this. Soccer ball is played, story problem. Soccer ball is played 10 feet away from a goal, which is 8 feet high. You kick the ball, it hits the crossbar on top of the goal. What is the angle of elevation of your kick to the nearest degree? Let's take it to the nearest degree. Story problem requires us to do that. So we got our soccer ball. We are 10 feet away from the goal. The goal is 8 feet high, and it hits the crossbar. Oops. Okay. What is the angle of elevation of our kick? Angle of elevation, again, is taken from the horizontal, so this is the angle we're looking for. How do we set that up? Assuming, of course, that the goal is vertical. How do we set that up? Yeah. Why did you choose tangent? Yeah, because we have the opposite side here and the adjacent side here. So if opposite and adjacent is tangent, using our SOHCAHTOA. So tangent of x is opposite over adjacent, which is 0.8000. Now, the angle is unknown, so this is where we can use our chart. You may use your calculator as well using the inverse function, but again, the chart is almost easier for a lot of people. And we go to our chart, which is on. I'm going to give you a copy of that. Sorry about the yawn there. But it's page, 925, I think. Getting there. No, not A9. It is. 915, 925, found it. Okay. We go to the chart. We look up. It's a tangent, 0.800. That's pretty close to 39 degrees. So the nearest degree, that would be about a 39-degree angle. The other way of doing it, if you're using the calculator, is the tangent inverse of the ratio equals the angle. If you're using the calculator, that's the way it gets done. So remember, the inverse function gets used to find the angle. When we know the ratio, we look at the angle using the inverse function. Or we can use our chart. Either way. Half the problem here, of course, is drawing the picture and remembering that angle of elevation is this angle, not this angle. Okay, 39 degrees. It's a pretty steep angle. Find x. Now, here's where it gets tricky for a lot of people, because we have all these different techniques available to us now. We have trig, we have Pythagorean theorem, we have similar triangles, you have all sorts of things, special triangles. And we have to pick which one is the correct method at a given time. So we have to kind of look at the picture and analyze what's going on. It'd be very easy to look at this picture and try to apply 30, 60, 90 to it, but it's not 30, 60, 90, because we'd have to know, for example, this is a 30-degree angle or this is a 60-degree angle in order to use that triangle. So don't try to use special triangles automatically all the time. Some people make that mistake. Don't be that person. Look at the picture. What do I know? I know two sides of a right triangle. What's the easiest way to find the third side if I know two sides? Pythagorean theorem. X squared plus 12 squared equals 20 squared. So x squared plus 144 equals 400, so that's 300, 256. So x is the square root of 256. And before I start to try to simplify that and break it up, is that a perfect square? Yes, it is. What is that? 16. And the real beauty of the jacket is it's just a little bit small, so the sleeves stick out underneath. I think that's really what makes it awesome. Gotta love that. It's annoying even for me to see. I can imagine what it's like. You won't fall asleep easily today. Too bright. Find the area of this triangle. Now, people have done pretty well with solving the triangle, but finding the area is the next trick, and let's take it to the nearest tenth. First, we have to be able to find the area in order we have to find this side, because you know base times height divided by 2. How am I going to find that third side? Pythagorean theorem again. Now, x squared is that. What's root 65 squared? 65. So x squared is 35, so x is the square root of 35. Okay, so the area, making sure we finish the equation, area is base times height over 2. And if we wanted to be precise, I mean, I suppose I could multiply 65 times 35. 2275. Which would be 5 root 91 over 2. Can break that down. But probably in a problem like that, I'd say decimalize it to the nearest tenth or something like that. So we just take square root of 2275, parentheses, divided by 2. About 23.8. U for units. So again, just kind of setting these things up, making sure we read the problem and get that done. Right acute obtusor, not a triangle. This is converse of Pythagorean theorem. It's the only way we can do this. So again, we set it up. First off, is it a triangle? 5, 6, 9, does it make a triangle? Yes. So 5 squared plus 6 squared, 9 squared. That's 25 plus 36, 81. That's 61, 81. Oh, the third side is too long. Therefore, that triangle is obtuse. Remember, it's the third side, too big, too small. 8, 12, 15. 8 squared plus 12 squared, 15 squared. So 64 plus 144. That's 208, 225. Oh, that's too long. It's going to be obtuse again. 7, 24, 25. 7 squared plus 24 squared, 25 squared. So that's 49, 576, 625. Oh. That one's going to be just right. Now, hopefully some of you, when you saw 7, 24, 25, are getting to the point now where you're recognizing that as a Pythagorean triple. Remember, we've dealt with Pythagorean triples in the past. Things like 3, 4, 5, or 5, 12, 13, 8, 15, 17, 7, 24, 25. Those are groups of integers that for which a squared plus b squared equals c squared. And some of you may have seen 7, 24, 25. If you recognize that, you don't actually even have to show work. You can just write Pythagorean triple because it is a Pythagorean triple, and you can use that recognition as your reason why. If you don't want to show the Pythagorean theorem converse itself. Find x and y. Actually, I'll probably just give you 1 on the test. Let's just find x. All right? So again, 3 triangles. In fact, I think on the test, I actually, for the first, there are a couple of these problems. For the first one, I actually drew the 3 triangles right on the test for you to help remind you that that's how we have to set these up. So if I look at Big Papa triangle, Big Daddy, short side is x, middle leg unknown, long hypotenuse 18. Mama triangle, short leg unknown, long leg 10, hypotenuse unknown. Little baby triangle, short leg 8, middle leg unknown, hypotenuse x. I'm going to use first and third. So 18 over x equals x over 8. So x squared is 80 plus 64, 144. So x is the square root of 144, which is 12. But again, if you take the time to systematically set that up, it's pretty simple because, I mean, we can all go small, middle, long, right? Identify the shortest thing, put it down. Identify the middle, put it down. Identify the longest, put it down. Go to the next triangle. Small, medium, long. It should be pretty easy to do in most cases. All right. Special right triangles. Solve without using trig. Give all answers as exact values only, meaning no decimal approximations. Again, these are the special triangles, so we should not be using trig here. On the last test, there we put some of these on and said, give exact answers, and people use trig and give decimal approximations. Don't do that. You won't receive credit for that because this is about knowing our special triangles. 30, 60, 90 triangle. This side is 7. How long is x going to be? 14 and... Okay. Have we pounded these at you guys enough? Have we beaten you over the head with this special right triangle deal enough yet this year? I hope so. This one's a little trickier. It's isosceles, but this side is 9. If it was 9 root 2, that'd be easy because it'd be 9 and 9, right? But it's not 9 root 2. So we have to look at our model. I know it's leg root 2. So leg times the square root of 2 is 9. So the legs individually, I divide by the square root of 2. The legs are 9 over square root of 2, which I then rationalize to get 9 root 2 over 2. Now, even if you just got so far as this, leg times square root of 2 equals 9, so leg is 9 divided by root 2, and you made a mistake in the rationalizing part, you still get most of the points that way. So always show your work. Always show partway through. Show how you're setting it up. I've got too many people who just want to write down the final answer, and they write 9 over 2 or something like that. And it's just, you got to see how you found it to make sure you know you're a triangle. If you show me how you found it, I can definitely give partial credit, which is nice. All right, find sine, cosine, and tangent of A. Now here, all it's asking for is a ratio. All it's asking for is a ratio to find the sine, cosine, tangent of angle A. If this is angle A, which side is the opposite? The adjacent, and the hypotenuse must be 13. So, sine of A is 12 over 13, the opposite over hypotenuse. Cosine of A is 5 over 13, adjacent over hypotenuse. I put 15. Oh, sorry. 13. And tangent of A, 12 over 5. Yeah, opposite over adjacent. Okay. So it's opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. That's the way it works. SOHCAHTOA. Just set up the ratios. Approximate cosine 7/8 to 4 decimal places. How would you handle a problem like that? What would you do? Yeah, just go in your calculator and go cosine 78 equals. What are you at? 4 decimal places. 0.2079. Not 80? Wouldn't round up? Nope. 2791 is the next digit, so we stay down. Okay. Kelvin and Hobbes. From his tree fort 15 feet over the ground, Kelvin spots Susie at an angle of depression of 37 degrees. Kelvin can throw his snowball 38 feet. Is Susie in range? You familiar with Kelvin and Hobbes? Classic comic, one of my favorites of all time. All right. So, what do we have to do? We have to draw a picture. He is 15 feet above the ground. Okay. Angle of depression is 37 degrees. So, angle of depression has to be taken from the horizontal. So this angle has to be the one that's 37 degrees. So this side to the ground over here is still 15 feet. It says his range is 38 feet. So how far away is Susie, X, down here? Okay, Susie's down there. Calvin's up here. Which distance are we going to find right there? What function am I going to use? Tangent. So tangent of the angle is 15 over x. What do we do when the x is in the denominator? Switch them. 15 divided by tan 37. Oh yeah, she's only 20 feet away, well within range. Susie's getting a snowball to the backside of the head. Very sad. Okay. The rest of the comic strip, I think, is actually Susie like beating the pulp out of Calvin, just so you know. So. All right, find the value of x to the nearest tenth. 15 here indicates the angle, 15 degrees. How am I going to set this up? Can we use Pythagorean theorem? How about special triangle? We're stuck using what? Trig, okay? And by the way, has trig been as bad as you thought it was going to be when we first started doing trig? All you guys are like, trig, we can't do trig. It's way too hard to do trig. This is only geometry. And now you're all like going, yeah, trig, big deal, right? SOHCAHTOA, easy stuff. All right, so we said sine. Sine of 15 equals 2 over x. Again, we swap, because we swap the entire things when we do that. So x is 2 divided by sine 15. What do you get? 7.7. And that makes sense. Quite a bit longer than the 2. That's a pretty small angle. We would expect it to be quite a bit longer. Solve the triangle. When it says solve the triangle, what do we have to do? Find all the unknown parts, right? So, I know 2 sides. How can I find the third side? Pythagorean theorem, okay. So, find the third side. 6 squared plus 13 squared is c squared. It's 36 plus 169. 175, 205 equals c squared. Your perfect square is going to 205. I don't think so. Because it can't, even ones won't work because it's an odd number. So we're stuck with 9, which doesn't go in. 25 does not. 49 does not. No, nothing goes into 205. So that's the easiest we can get. Not done yet, though. I need to find my angles. Which angle would you like to find, A or C? You have a choice. A, all right? Kind of unanimous on that A thing there. Impressed. All right, so if we want to find angle A, which function are we going to use, sine, cosine, or tangent? Tangent. We would not use the root 205 just in case we made a mistake there. So tangent of A is 13 over 6. Which we could approximate as a decimal to 4 places. That's 2.1667. Then we could go to our chart, or we could look it up in our calculator. Either way, I'm getting really close to 65 degrees. 65.2 in the calculator. Okay, so this is about 65 degrees, making this about 25 degrees down here. No. It'll probably say the nearest degree or whatever, so that would be fine. If you use a calculator, use 65.2, and that to 1 decimal point extra doesn't bother me. When you start taking out like 6 decimal points, that's just obnoxious. Don't do that. Find the measure of the angle that completes the equation. This is all just lookups. Or using your calculator. Tangent of A equals 0.456. I'm going to get 24.5 degrees about. How about sine of B is 7/13? So I have to do the sine inverse on that one. I get 32.6 degrees. Cosine of C, so second function cosine. I get 58.6 degrees. So again, we have a variety of methods, yes.
Do you want us to keep them in decimals or like rounded and near?
See what it says on the instruction of the test and something like this. If you're doing a calculator, round to the nearest tenth. If you're doing it from the book, just do it to the nearest degree. I'll give you some leeway because some people are using different ways. But if it can be accurate, go ahead and do it. That's it. That's a review. Those are the things you can expect on the quiz tomorrow, on the test. Really, solving right triangles. Special right triangles, Pythagorean, lots of Pythagorean theorem. I mean, some of the hints you'll get on the test, when it says give the exact value, no decimals, you know you aren't going to use trig on that. So be careful and be prepared. You should be plenty prepared. We've had plenty of time to do this, including an extra day, so should be good to go. All right, good luck. And if you need extra help, be sure to stop in.